In this video, I want to give you a version of the fundamental theorem of calculus for you to put onto page 592 of your workbook, and then we will skip over the rest of page 592 and do a few examples on page 593. All right, and so here's kind of all of the parts of the fundamental theorem of calculus, that if f is continuous over some closed interval, and we define f of x, big F of x, is the integral from a to x. A is any real number. In those problems on the last page, we used 1 there. There was nothing special about 1. Any real number we use there is going to give us a constant term that's just going to get taken out when we take the derivative. To x of f of t dt, little f of t dt, then the derivative of big F of x is equal to just little f of x. And if we're taking the derivative with respect to some function, we just use the power rule. I'm sorry, the chain rule. And so this is little f of u of x times the derivative of u with respect to x. Okay, so that's the way that can be written out. Throw some notes in here in addition if you think that you could use that. So all they're saying in the rest of this page is either you could calculate this definite integral by finding antiderivatives of these functions and then take the derivative and you would get an answer, but you can take a shortcut just by using the second fundamental theorem of calculus. The big advantage of the second fundamental theorem of calculus, or the first fundamental theorem of calculus, is that this works even if we can't figure out what this antiderivative is, even if there isn't an antiderivative at all. So here are some more complicated functions. And so finding the derivative of this would be a bit of a mess. All right, so finding an antiderivative of the square root of 2 minus t squared, I'm not going to say that's impossible, but it's unpleasant. It's not something we're going to cover in this class. And e to the cosine of t is going to be harder yet. I'm not even sure there is a simple function that has this as its derivative. But these are easy to do by using the formulas we talked about on the last page. So since this is a function of x here, all we're going to do is we're going to take the square root of 2 minus 2x squared. All I did was substitute 2x in for t squared. And then I'm going to multiply this by the derivative of t squared, which, why don't I put the 2 up in front there? All right. What's different about this problem here that we haven't seen so far in problems of this type? Well, this is a little bit weird in that the variable bound of integration is the lower bound and not the upper bound. Remember when we talked about the properties of the definite integral, we can swap the upper and lower bound so that we can apply the fundamental theorem of calculus as we know it, but there's a price for swapping the upper and lower bounds. Do you remember what that is? What we need to do is we need to swap the sign. So that becomes the negative of the definite integral from -3 to x squared of e to the cosine of t dt. And now that the variable in the integration is in the upper bound, pause the video and give this a shot. All right, so we've got that negative, so we're going to keep that there. And what we're going to do is we're going to take our variable bound of integration, substitute it in for t, e to the cosine of x squared, and we're going to multiply this by the derivative of x squared. So that is -2x times e to the cosine of x squared. All right, and this last problem, this time we're back the way we're used to seeing it. So h prime of x is equal to, once again, pause the video, give this a shot, and then double check to see if I got the same answer. So it's cosine of x squared We usually write it like that. And then we're going to multiply it by the derivative of cosine, which is negative sine of x. So negative sine of x, cosine of x squared. All right. So this is definitely the kind of question that they will ask on the multiple choice section of the AP exam. It looks like a super hard problem, especially if they give you something here that's hard to find an antiderivative of. But if you keep that fundamental theorem of calculus in mind, you can see it's just a simple substitution and you are on your way to the next problem. We'll take a look in the next couple of videos at some short answer problems that are going to sometimes have us use the fundamental theorem of calculus and sometimes have us use other properties that we've used before over this course.